Hello, today's class is about similar polygons. Remember, polygons are two-dimensional shapes with sides and angles. Two shapes are similar if they have all angles congruent and all sides proportional. There are two conditions that need to be fulfilled in order to prove that two shapes are similar. You obtain a similar shape by enlarging or by reducing a given shape with a certain scale factor. The highlighted words are the keywords of today's class. First of all, you need to be able to check if given polygons are similar. Here's an example. We have given 4 rectangles. Because being rectangles, they each have only right angles. We don't need to prove that the angles are congruent. Therefore, we only have to check if the sides are proportional. For rectangles A and C, small side of rectangle A over small side of rectangle C, the first part of the proportion, the first ratio. Now second side of rectangle A over second side of rectangle C. Because the two ratios are equal, they form a proportion. 2 over 6 it is equal to 5 over 15. This is true. Therefore, rectangle A is similar to rectangle C. This is a sign you've used today for the first time. Similar. And this is a sign that you probably didn't use before, therefore. So rectangles A and C are similar because they have proportional sides and all pairs of angles are congruent. Congruent, that's a fancy math word for equal length, equal measurement. We're going to check now if rectangles A and B are similar, and because the sides are not proportional, you see this proportion is not true. Small side of A over small side of B, 2 over 6, is not equal to 5 over 8. Therefore, rectangle A is not similar to rectangle B. Here I have the similar sign crossed with a bar, not similar. We're looking now at rectangles B and D, and again, small side of a rectangle over small side of the other one, 3 to 6. Big side of a rectangle over big side of the other one. 3 over 6 is the same with 4 over 8. Therefore, rectangles B and D are similar. Example 2. This time we are given few triangles to check if they are similar. If we look at the angles in these triangles, we're looking for triangles that have 3 pairs of congruent angles. Let's fill out the missing angles that are not given. Sum of the angles in any triangle 180, 50 plus 90, 140, which means this angle is 40 degrees. 100 with 40 degrees missing here. 130, 50 degrees missing here. The only two triangles with 3 pairs of angles congruent are triangles A and D. Therefore, the two triangles are similar. All the others are not similar because they do not have all 3 pairs of angles congruent. Now, for triangles to be similar, it is enough to prove that all pairs of angles are congruent. For any other polygons, we would have to check not only the angles being congruent, but also if sides are proportional. To answer the question, triangles A and D are similar because they have 3 pairs of congruent angles. Another thing we would have to be able to do when talking about similar polygons, we will need to be able to find the scale factor, and the scale factor of 2 similar polygons is the ratio of the sides of the 2 polygons, ratio written in simplest form. We are given 2 parallelograms, and we are told that they are similar. The scale factor as a ratio of corresponding sides. Big triangle over big triangle, 4/12. Small triangle, I go back, I said something silly. Big side over big side, 4/12. Small side over small side, 3/9. Notice that both 4/12 and 3/9 in simplest form can be written as 1/3. Therefore, the scale factor of these 2 similar parallelograms is 1/3 or 1/3. Another use of similar polygons, given that some polygons are similar, we would have to find missing sides. In this example, we have two similar trapezoids. Because the trapezoids are similar, the corresponding sides are proportional. I can write the proportion using these sides. So again, small side over small side, you see here 2/x equals big side over big side. See here 3.8 over 5.6. I have a proportion. I can solve it by cross multiplying the way you know by now. And here I solve this proportion for x. I am able to find the missing side of a shape when I know that the two shapes are similar. The last thing that we will use similar polygons for is what is called indirect measurement. Indirect measurement is a method of calculating a size of an object that I cannot measure using dimensions that I can measure. And a classical example is having a person with a known height. I can measure the person's shadow on the ground, and we have to find the height of a tree as we are able to measure the length of the shadow of the tree. Now the question is, here are the which are the triangles, right? We were talking about similar shapes. Which are the similar shapes here? This is a triangle made by the person, its shadow, and the sun ray. The other triangle is made by the tree, its shadow, and the same sun ray. On a side here, I drew the triangles separately, hoping that it is easier for you to understand. You see the two triangles? Now we assume that the tree and the person are both vertical. They make 90-degree angles with the ground, and the sun rays make the same angle with the ground. This is the angle made by the sun ray and the ground. Why are the two triangles similar? This is the question that you will have to answer. With the two triangles similar, their sides are proportional. So person's height over tree height is in the same ratio as shadow of the person to shadow of the tree. If three of the terms of the proportion are known, you can solve the proportion and find the fourth term. In our case, the fourth term is the height of the tree, the one dimension that is difficult to measure, and that's why we use indirect measurement to find it. Now you will have to answer some questions in your notebook.